In this episode, let us learn about some best practices for improving efficiency, performance, security, governance, and cost of a retrieval augmented generation system. The first guidance for optimizing the efficiency is to optimize the chunking strategy based on retrieval patterns and document structures. Instead of always using fixed size chunking as a default, you should evaluate techniques such as recursive chunking or semantic chunking, which often preserve the context better. Having the right chunking strategy improves relevance and it also reduces unnecessary tokens. Second guidance is to apply metadata filters before performing a vector search. Instead of searching the entire vector database, you should narrow down the candidate set using metadata filters such as date, topic, user permissions, etc. This improves relevance and it also reduces latency. Third guidance is to cache the retrieval results and embeddings wherever possible. Embedding generation can be expensive, especially at scale. If documents have not changed, do not recompute embeddings repeatedly. And for frequently repeated queries, consider caching the results to improve the response time and system throughput. The fourth guidance is to implement a course to fine retrieval for large datasets using two indexes. Maintain a course index that splits the documents into larger sections and maintain a fine index that splits the documents into smaller passages. Use contextual metadata to correlate chunks in the two indexes. At the time of retrieval, you should retrieve relevant sections from course index first and then use metadata filters to narrow down retrieval within the fine index. This will reduce unnecessary vector comparisons, will lower your retrieval cost, and improve scalability, especially for larger datasets. The fifth guidance is to optimize top K retrieval. Retrieving more chunks does not always improve the answer quality. In many cases, retrieving only the most relevant 5 to 10 chunks instead of dozens of passages can reduce latency and downstream LLM cost while still maintaining strong response quality. For improving the retrieval quality and performance, the first guidance is to implement hybrid search wherever applicable by combining vector search and keyword-based BM25 search. The vector search captures semantic meaning, whereas the keyword search helps match the exact terms, product names, IDs, or acronyms. Using both together typically improves retrieval accuracy for many use cases compared to either approach alone. The second guidance is to use re-ranking models after initial retrieval stage. The first retrieval step usually returns a broad candidate set. Re-ranking models can rescore these results and prioritize the most relevant chunks for sending to the large language model. This often improves answer quality significantly. The third guidance for improving performance is to use query expansion or query decomposition techniques when your user questions are ambiguous, incomplete, or phrased differently from the source documents. Query rewriting techniques can help generate clearer retrieval queries and improve the relevance of retrieved context. The fourth guidance is to choose the right embedding model, which is based on domain and language. General purpose embeddings may work well for broad use cases, but can underperform in specialized domains such as legal, medical, finance, or source code retrieval. Domain-specific embeddings often improve the semantic matching accuracy. Often, a poor large language model response is because of the poor retrieval quality due to wrong embedding model. And finally, continuously evaluate retrieval quality using metrics such as recall, precision, groundedness, faithfulness, answer relevance, etc. Evaluation frameworks that use a large language model as a judge can help identify retrieval weakness and improve system reliability over time. Ragas is an example of such an evaluation framework. To improve security of a retrieval augmented generation system, you can implement document level access control. Retrieval systems should only return documents that a user is authorized to access. This is commonly enforced using metadata filtering based on permissions, roles, tenants, or access groups before retrieval occurs. Retrieval security is just as important as application security because unauthorized chunks should never reach a large language model context. Second guidance is to have an intentional focus on protecting against prompt injection attacks. Malicious instructions are designed to override system prompts or manipulate model behavior. To reduce this risk, you should isolate the retrieved context using delimiters in structured prompts. You should also detect and sanitize any suspicious instructions and use moderation or guardrail models to scan the retrieved context before it reaches the large language model. The third guidance is to encrypt embeddings and vector databases. Embeddings, metadata, and retrieved context may contain sensitive enterprise information. Therefore, encryption should be applied both at rest and in transit to protect the data from any unauthorized access or interception. Fourth guidance is to avoid storing any sensitive data such as PII, secrets, credentials, or any regulated data in vector embeddings unnecessarily. Build pre-processing pipelines to redact, mask, tokenize, or sanitize data before storing it as an embedding in the retrieval system. And finally, audit and log retrieval activity by maintaining detailed audit trails showing who queried which document and when. Logging retrieval activity is important for compliance, governance, any incident investigation, and monitoring suspicious behavior. For implementing governance in a retrieval augmented generation system, you must track document lineage. Retrieved chunks should include source attribution metadata such as document name, version, section, or page number. This will allow generated answer to reference original sources and improve explainability, traceability, and user trust. The second guidance is to version your embeddings and indexes. Organizations should track embedding model versions, chunking strategies, and ingestion pipeline versions using metadata on the chunks. They should also version the indexes. This will help team diagnose any changes in the retrieval quality and safely roll back updates when needed. The third guidance is to establish data freshness policies. This ensures that only accurate and up to date information is retrieved. Define clear SLAs for how frequently documents should be reindexed and how stale content should be removed. This improves cost, relevance, and speed of retrieval. Retrieval systems should also be regularly synchronized with upstream data sources. The fourth guidance is to implement human review workflows for any critical domains such as legal, financial, or compliance sensitive applications. In high impact scenarios, the generated responses may require approval, escalation, or human validation before they can be presented to the end user or acted upon. And finally, define evaluation benchmarks and guardrails before production deployment. Organizations should standardize evaluation datasets, hallucination thresholds, toxicity checks, groundedness requirements, and other quality metrics to ensure that retrieval augmented generation systems behave reliably and safely at scale. For cost, the first guidance is to reduce context size aggressively. Every unnecessary chunk that is sent to the large language model will increase the prompt token usage and overall inference cost. Retrieval systems should only send the most relevant context that is needed to answer the query accurately. You can implement this by applying techniques such as the right chunking strategy or re-ranking. Second guidance is to use smaller embedding models when sufficient. Larger embedding models may improve retrieval quality marginally in some cases, but they also increase embedding generation cost, vector storage size, indexing overhead, and potentially retrieval latency due to higher dimension embeddings. You should evaluate the embedding models to find the right size for your use case. Third guidance is to use multi-stage retrieval pipelines by using re-ranking models. Common pattern is to use inexpensive retrieval methods to first narrow down the candidate sets and then apply more expensive re-ranking models to top results. This avoids applying costly operations such as calling a large language model for re-ranking across entire dataset. Fourth, use tiered storage and indexing. Frequently accessed or hot data can be stored in fast, high performance vector index, while the older or rarely used cold data can be archived in a lower cost storage tier. This helps optimize the infrastructure spending at scale. And finally, continuously monitor token and retrieval usage for proactive cost control. You should monitor metrics such as prompt tokens, vector database queries, re-ranking usage, cache hit rates, etc. for identifying inefficiencies and controlling operational costs as retrieval augmented generation system scales. So, these were some of the best practices that you can apply to improve the efficiency, performance, security, governance, and cost of a retrieval augmented generation system.